Okay, so this starts section 6.5, and it's going to be talking about the sum and difference formulas for all the trig functions, well, sine, cosine, and tangent. So we're going to start with the sum and difference formulas for cosine. Okay? And the formula are these two right here, and these you need to write down. Okay? You will be expected to memorize them, so write them down, highlight it, do whatever you need to do. You have to know these. So cosine of alpha plus beta, keeping in mind that these are two angle measures, can be written as cosine of alpha times cosine of beta minus sine of alpha sine of beta. If it's cosine of alpha minus beta, it can be rewritten as cosine of alpha cosine of beta plus sine of alpha sine of beta. So let's look at an example of using these. So let's say we're asked to find the exact value of cosine of 75 degrees. Now, 75 degrees is not one of our known angles on the unit circle, so we want to rewrite 75 degrees to include measurements that we know about. So we're going to rewrite cosine of 75 degrees as cosine of 45 degrees plus 30 degrees. Okay, so this puts it in the format of our first theorem. So the 45 degrees is like our alpha, and the 30 degrees is in the spot of the beta. So now we use this formula, and we can rewrite this as cosine of 45 degrees times cosine of 30 degrees minus sine of 45 degrees times sine of 30 degrees. And then using our knowledge of the unit circle, cosine of 45 degrees is the square root of 2 over 2. Cosine of 30 degrees, is square root of 3 over 2. Sine of 45 degrees is the square root of 2 over 2. And sine of 30 degrees is 1/2. So multiply here, subtract here, multiply here. All right. So, now that we've got just a bunch of fractions, this becomes the square root of 6 over 4 minus the square root of 2 over 4. I'm just making it into one big fraction. It'll look like the square root of 6 minus the square root of 2 over 4. And then that's your final answer. Okay, so these are going to be exact answers. There's going to be no calculators, and there's going to be kind of funky looking answers like this. Let's take a look at another example. Okay, so let's find the exact value of cosine of pi over 12. Now again, pi over 12 is not one of the nice radians on our unit circle, so we have to use two radians that we know about. Now in order for a common denominator to be 12, we know that we're going to have to use fractions that involve 4 and 3. So pi over 4 and pi over 3. Now let's just try adding those two together, see what we get. Common denominator for 4 and 3 is 12. Need to multiply this side by 3. Multiply this side by 4, that becomes 3 pi plus 4 pi, which would give us 7 pi. Well, I want 1 pi over 12. So is there a way that I could use 3 pi and 4 pi to get to 1 pi over 12? Sure. So instead of adding, we're going to subtract them. So we'll use pi over 3 minus pi over 4. And just checking to make sure it works. Common denominator there is 12. Times 4 would make your first fraction 4 pi over 12, times 3 would make your second fraction 3 pi over 12, which gives us 1 pi over 12, which is what we want. So I'm going to rewrite cosine of pi over 12 as cosine of pi over 3 minus pi over 4. And in this case, pi over 3 is our alpha, and pi over 4 is our beta. So using our formula, we rewrite this as cosine of pi over 3 times cosine of pi over 4 plus sine of pi over 3 times sine of pi over 4. And using our knowledge of the unit circle, cosine of pi over 3 is 1/2 times cosine of pi over 4 is the square root of 2 over 2. Big fat plus sign, big fat plus sign. Sine of pi over 3 is the square root of 3 over 2 times sine of pi over 4 is the square root of 2 over 2. So when it's all said and done, we've got the square root of 2 over 4 plus the square root of 6 over 4 Our final answer is the square root of 2 plus the square root of 6 all over 4. All right, now let's take a look at an example like this one. So it says find the exact value of cosine of theta minus pi over 2. In this case, they've already given it to us written in the format of the formula. So in this case, our alpha is theta, and in the beta spot is pi over 2. So again, we'll just use our formula to rewrite this as cosine of theta times cosine of pi over 2 plus sine of theta times sine of pi over 2. Now we don't know what theta is, so we can't really do anything with that piece, so we'll just leave it as cosine of theta. But cosine of pi over 2 on the unit circle, we know that that's 0. Plus, have no idea what theta is, so this just remains sine of theta times sine of pi over 2 is 1. 0 times anything is 0. So cosine of theta minus pi over 2 equals sine of theta. Now this is actually something that you can see pretty easily on a graph as well. If you think about transformations, a minus pi over 2, that means that you would go to the right pi over 2 units. So your normal cosine, you got 2 pi, pi over 2, 3 pi over 2. Goes from 1 to negative 1. Now cosine normally starts up here and goes down. Now if you want to go to the right, pi over 2 units, that means you're jumping to the right 1 tick mark. So this tick mark comes over here, 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 here. Okay. So now the graph looks like this, which is the same thing as the sine curve. So it makes sense that cosine of theta minus pi over 2 equals sine of theta. All right, so let's talk about the sum and difference formulas for the sine function. All right, write these down, highlight them, do what you need to do because you have to memorize them. Sine of alpha plus beta can be rewritten as sine of alpha times cosine of beta plus cosine alpha sine beta. And sine of alpha minus beta equals sine of alpha times cosine of beta minus cosine alpha sine of beta. All right, and then we're going to look at this example, sine of 7 pi over 6. Now, 7 pi over 6 is not on our unit circle, but we just played around with the pi over 3 and pi over 4 when we were trying to find 1 pi over 12. So we actually know that 7 pi over 12 is the same thing as pi over 4 plus pi over 3. So I'm going to rewrite this as sine of pi over 4 plus pi over 3. So here, pi over 4 is alpha and pi over 3 is beta. Rewriting it using this formula right here, this is sine of pi over 4 times cosine of pi over 3 plus cosine of pi over 4 times sine of pi over 3. And then sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3 is 1/2. Big fat plus sign, big fat plus sign. Cosine of pi over 4 is the square root of 2 over 2. And sine of pi over 3 is the square root of 3 over 2. So our final answer is going to be the square root of 2 plus the square root of 6 over 4. So that's using our sum and difference formula for sine. Let's take a look at if the problem was written. Oh, I guess I should also say this. With this example, it wouldn't matter since it's addition. You could have started off writing it as sine of pi over 3 plus pi over 4. Since it's addition, it wouldn't matter. And if you work that all out, you would have gotten the answer to look like the square root of 6 plus the square root of 2 over 4, which is the same thing as what we got. So either way, since it's addition, you can do that. All right, now let's take a look at this one. Sine of 80 degrees times cosine of 20 degrees minus cosine of 80 degrees times sine of 20 degrees. All right, now neither 80 degrees nor 20 degrees is one of the nice angle measures on our unit circle. We don't know what those values are. But you should recognize that this is written, oops, wrong one, sorry. This is written as the right-hand side of the the difference formula. So what we're going to do is we're going to condense it down to look like the left-hand side. So in this case, the alpha is the 80 degrees and the 20 is the beta degrees. So condensing that down, we know that this is the same thing as saying sine of 80 degrees minus 20 degrees, which becomes sine of 60 degrees, which is great because that actually is on the unit circle. We know about that one. And sine of 60 degrees is the square root of 3 over 2. And that'd be our final answer. All right. So last formulas for tangent. Okay. That's supposed to be just one nice big fraction bar there. I'm not sure why it did that. But take a moment, write those down, please. All right, so let's take a look at tangent of 7 pi over 12. Again, we know that 7 pi over 12 is the same thing as pi over 4 plus pi over 3. So we're going to look at using our sum formula for tangent. So I know that I can rewrite this as tangent of pi over 4 plus tangent of pi over 3 all over 1 minus tangent of pi over 4 times tangent of pi over 3. Okay, so tangent of pi over 4 is 1 plus tangent of pi over 3 is the square root of 3. Down here, this becomes 1 minus 1 times the square root of 3. So I'm looking at 1 plus the square root of 3 over 1 minus the square root of 3. Now we don't really like to leave it that way because we don't like square roots on the bottom of a fraction. And the way we get rid of that is that we multiply by the conjugate. So we multiply both the top and the bottom by 1 plus the square root of 3. Okay. So in the denominator, we know our middle terms will cancel out, so that's going to become 1 minus 3, or negative 2. And on the top, when you FOIL that out, that's going to look like 1 plus, excuse me, 2 square root of 3 plus 3. And then you have the 1 plus 3, so we know that that's going to make 4 plus 2 square root of 3 all over negative 2. And then you can reduce that because 4 is divisible by 2, 2 is divisible by 2. You have a positive divided by a negative, so negative 2 minus the square root of 3. And that's our final answer. Okay, so using those formulas, your assignment for tonight is going to be on page 509, numbers 12 through 32 even. Good luck.